Today we're going to continue our review of all things algebra that we've talked about so far, and we have landed on solving equations. So here's where we're going to combine our knowledge of performing inverse operations in reverse order and other techniques for when our equations involve more than one instance of the variable. All right, let's begin. The primary way we want to solve equations is to perform inverse operations in reverse order. And then we have to remember some extra things. So the main thing that we want to look at is remind ourselves what inverse operations are. So we have to know what the inverse operations are. So we know that the inverse, so we know some inverses. Addition and subtraction are inverses. Multiplication and division. So what I mean by inverse operations, I mean addition and subtraction. Multiplication and division. And then exponents and reciprocal exponents. The inverse of an exponent is a reciprocal exponent. Now, this one goes further because there's even more that goes along with exponents. So in the inverse operations department, we've got addition and subtraction, multiplication, division, and we've got exponents and reciprocal exponents. But there are some other things that we have to recognize with exponents. So in particular, radicals represent fraction exponents. Radicals are fraction exponents. The index is the denominator. The index of the radical is the denominator of the exponent. The index of the radical is the denominator of the exponents. So an x to the 1/3 power is the same as a cube root of x. The index of the radical is the denominator of the exponent. So in this way, the inverse of a cube is a 1/3 power, or also a cube root. The other thing that we can get away with exponents is that negative exponents make denominators. Negative exponents make reciprocals. Maybe is a better way to phrase that. Negative exponents make reciprocals. Negative exponents make reciprocals. So if I have, what I mean is that if we have an x to the -3 power, that's 1 over x to the 3rd, or 1 over x to the -5 is x to the 5. So a negative exponent in the numerator is a positive exponent in the denominator. A negative exponent in the denominator is a positive exponent in the numerator. Then we can imagine that's over 1, and this one we can imagine being over 1. So some things to remember with exponents. Now, these are both things that we need to solve for a base. In addition to solve for an exponent, we need logarithms to solve for exponents. So to solve for an exponent, we need logarithms. So in the other exponent in equation categories, if the variable is the exponent, then we use logarithms to solve for the exponent. So this is how we turn things around. So for example, if we have some b to the x is equal to y, this means that x, to figure out what the exponent is, we write the log base b of y. This is not an expression that we can take to our calculator directly, so we can use the change of base formula. So we can say this is log of y divided by the log of b. So we use the need the change of base formula to get to calculator logarithms. So some calculators will have a log base b button, but it's buried in a menu. So let's see if I can even remember where it is on the TI-84. Oh, there we go. Log base. Log base. I can't remember what order we put things. They don't even write it in the right order. So when I write log base 8, 2, it's log base 2 of 8. So, you know, at least they're trying. Good job, Texas. Pretty good. But if we just do the log of 8 divided by the log of 2, that would be the log base 2 of 8. So we need to use logarithms to solve for exponents. So there's a lot of extra stuff that goes along with exponents. As you move through your math classes, you're going to find more functions and learn about their inverses. So you're going to learn about trigonometric functions, and you're going to learn about inverse trigonometric functions so that you learn how to undo those. But your core technique is still going to be perform inverse operations in reverse order. And then we'll need other techniques, specifically when the variable appears more than once. So I prefer thinking of solving equations in this fashion. Your default should be to try to perform inverse operations in reverse order. Other techniques are for when the variable appears more than once. If the variable does not appear more than once, you should be doing inverse operations in reverse order. So that way, inverse operations in reverse order becomes the default, and other techniques become the niche techniques. A lot of times we spend a lot of time doing a thing in a math class, and it kind of gives the impression that that thing is the thing that happens most often. We didn't spend a lot of time factoring polynomials, but if I want you to practice factoring polynomials, I hand you a big stack of polynomials, most of which are factorable. But that does not reflect the reality of the situation. Most of the time, if you just encounter a polynomial at random, it's not factorable, not in the ways that we have you practice factoring polynomials. But you have this bias built in by the way that we teach you factoring polynomials. The way we teach you factoring polynomials builds in this bias that most polynomials are factorable. But That bias is based purely on your experience. That's saying most polynomials are factorable because because most of the polynomials that I have personally encountered are factorable polynomials. But that is not how things work. Just because something is your experience doesn't mean it's everybody else's experience. This applies to almost everything else that we can think of. Just because something is your experience doesn't mean it's everybody else's experience. Just because most of the polynomials that you have encountered in your mathematical career are factorable does not mean that most polynomials are factorable. That's just the experience that you've had. I find it difficult to make turns when there is a truck or a van parked on the corner. And this is because my car is short. It is not the experience that most people encounter. My car happens to be shorter because when I drive a taller car, I can see around the truck. Unless it's a lifted truck, in which case I'm annoyed anyway, for multiple reasons. Just because something is your experience doesn't mean that everybody else has the same experience. When I was in school, I was told to go get a degree in science and you'll be able to find a job, no problem. So people my age are out here trying to tell people y'all's age that that's what works, but that was their experience. And if they would spend some time talking to younger people, they might realize that that is not the experience in general. Just because something happens to you doesn't mean it's going to work that way for everybody. Anyway, so that's all to say. I want to change the default way to think of solving equations as performing inverse operations in reverse order and use other techniques for when more than one variable appears more than once. The other thing that I need to point out for the exponents is that if we have an even integer exponent, we're going to have two real solutions. So also in the category of exponents on the list of things that we have to remember, equations with even integer exponents will have two real solutions. Oh, two or zero real solutions. Equations with even integer exponents will have two or zero real solutions. So if e to the x, for example, I was going to write example, then I translated into math, I was going to write e to the x, both of which are not things that I wanted to write. If, for example, we have an equation that says x squared is equal to 4, I'm going to use 9. If x squared is equal to 9, we have two real solutions, x equals 3 and x equals -3. Since 3 squared is 9 and -3 squared is equal to 9. Even integer exponents, two real solutions. It could be zero real solutions. So for example, if x to the 4th is equal to -16, there are no real solutions. If we take a real number and raise it to an even power, an even number raised to an even power must be positive, because a negative times a negative is a positive, and a positive times a positive is a positive. So if I have 4 negatives lined up, The first two make a positive. The positive times a negative makes a negative. The negative times that fourth negative makes a positive again. So equations with even integer exponents could have 2 or 0 real solutions. I usually phrase this by saying even exponents do not respect negatives. They try to make everything positive. Takes that -3, even exponents, positive 9. Odd exponents just give you negative real solutions, so that's fine. So if x cubed is equal to 8, then we get 1 real solution, or -8. So x cubed is equal to -8. We have 1 real solution. X is -2. Since -2 cubed is equal to 8. 3 negatives. A negative times a negative makes a positive. Positive times a negative makes a negative. Although I keep forgetting to write my negatives. Right. This has led us to our first niche technique for when a variable appears more than once. So our first technique for when a variable appears more than once is the quadratic equation. So quadratic equations, I don't know why black ink is not getting along with me today. Quadratic equations are the first type of equation where the variable appears more than once. So quadratic equations specifically in standard form. So quadratic equations in standard form, it's the first time we have to use a different technique. We can't do inverse operations in reverse order because a quadratic equation in standard form will look like ax squared plus bx plus c equals 0. The variable appears more than once, so we can't do inverse operations in reverse order. We can't just inverse operations in reverse order because the variable appears more than once. There's an x squared, but there's also an x. We can use the quadratic formula, which is trash, but we can use it. But we should recognize where the quadratic formula comes from. The quadratic formula comes from rewriting our standard form in vertex form. So our other technique is to switch to vertex form. The main thing that we have to remember here is that the x-coordinate of the vertex is minus b over 2a, and then k is just the function evaluated at h. Then we can rewrite ax squared plus bx plus c equals 0 as a times x minus h squared plus k equals 0. So our other technique, which is switching to vertex form, allows us to do inverse operations in reverse order. So now, from vertex form, we get to use inverse operations in reverse order. Inverse operations in reverse order. IOIRO. Or maybe I should do inverse operations in reverse orders. IORO. IORO? IORO? I don't know. But once we have things in vertex form, we can do inverse operations in reverse order. So in this case, we would just solve. Take 0, subtract k, divide by a, do a plus and minus for the square root, and add h. So h plus or minus the square root of minus k over a. This is equivalent of using the quadratic formula. Takes out a couple of the steps, changes the order a little bit. Just as a reminder, the reason that I prefer this x equals h plus or minus minus k over a is that when we're looking at, this emphasizes the fact that we're looking for the middle, the vertex, and in the middle is the axis of symmetry. I think I made them orange all the time. Here's where x is equal to h. And then we plus or minus the square roots of minus k over a. So on here is where we do plus the square root of minus k over a. And on the other side is where we do minus the square root of minus k over a. So there's the plus and the minus from the middle. So I like this form better than the generic quadratic formula because this form emphasizes the shape. It exploits the shape in the parabola. Also, here's our vertex at h and k. Vertex is at h and k. And so if we see that h is negative and a is positive, then I've got k is negative means the parabola vertex is below the x-axis, and a positive means it opens up, which means we're going to have two solutions. But if k is positive and a is positive, then we're doing the square root of a negative, and that means the vertex is above the x-axis and the parabola opens up, which means we'll have no real solutions. Similarly, if k is negative and the a is negative, then minus k over a will still be negative. Parabola opens down and the vertex is below the x-axis, so there'll be no real solutions. But if k is negative and a is positive, then we'll do the square root of a positive number. The vertex is above the x-axis, and there'll be two real solutions. So we can see that by when we look at the vertex and the direction that the parabola opens, we can use the geometry of the parabola to determine if there's going to be two solutions or one solution. Furthermore, if k is equal to 0, that means the vertex is sitting on the x-axis. And so we'll just have one solution, but there'll be two copies of it because it'll be an x minus h squared. And then it'll be plus and minus nothing. So that means the vertex is sitting on the x-axis. So that gives us all those possibilities. So here we have A is positive. If A is positive and K is negative, 2 solutions. If A is positive and K is positive, no solutions. If A is negative and K is negative, no solutions. And if A is negative but K is also negative, oops, K is positive. K is positive. Then we'll get 2 solutions. And then in the middle, here we have A is positive, but K is equal to 0. And here we have A positive and K is equal to 0. Things that can happen with parabolas, where y is a function of x. All right, I just wanted to put out an overall review of solving equations. I want the primary focus to be trying to perform inverse operations in reverse order. And I want us to think about other techniques are for when the variable appears more than once. Our first strategy with quadratic equations was to rewrite the equation so that a variable did appear only once. In standard form, the variable x appears twice, but in vertex form, the variable appears only once. So we get to use inverse operations in reverse order. There's an exponent that's an even integer. That's why we get 2 or 0 real solutions, because there's the plus minus and the square roots. Notice that this square root is the 1/2 power. That's the inverse of the exponent of 2. Everything else is just addition, subtraction, multiplication, division. All right, that's going to do it for today. I will see you all on tomorrow. Everybody have a good day, and thanks.
Professor Leach, I have a question about the finals.
Yes.
So when I tried to do the final, it said that the module wasn't available. Is it supposed to be, are we supposed to have it completed at a later date, or has it not dropped yet?
That's strange. I'll go double check. I might have the module set to a wrong date. The finals should be up there. I'll go double check to make sure that the finals are available.
All right.
There should be a module called Final Series Quizzes, and that'll be at the top of the modules, top of the homepage.
It says that it's locked and it's part of an unpublished module at the moment.
Oh, let me go in and publish it. Try refreshing your page to see if it appears published now.
Oh, now it does. Thank you.
Okay, I must have had it. Maybe I had it set to today. That's weird. So it should be available now. There are 5, and those will be 5 out of 10.
All right. Thank you.
All right. Have a good day.
You too.
All right. Thanks for playing, everybody.